Hey guys, welcome back. Today we have another problem from the balanced bracket category. Given a string containing just the characters open bracket and close bracket, find the length of the longest valid parenthesis substring. For this input, output is 2. Why? Because this is the balanced bracket substring, right? And for the second input, the middle 4 characters are balanced, right? That's why output is 4. But let's say this input will be like this, then the output should be 6. Why? Because the last 6 characters are the longest balanced substring. So how should we approach this solution? If we see this problem closely, we are talking about substrings. And when we talk about substrings, actually we are dealing with contiguous characters, right? Now one solution can be find all possible substrings from the given string and find the max length. It is definitely a good solution, okay? You can definitely tell this approach in an interview, okay, when you don't have a better solution, okay? This is the naive and this is the brute force approach, I can say, okay, which is actually a n cube, O of n cube time complexity. Why? Because finding all the substring is O of n square. So you will be doing another O of n operation to check whether the string is balanced or not, right? So that's why it is O of n cube, okay? If you don't know how to check whether a string is balanced or not, refer to one of my previous video, okay, before watching this, because I'm going to talk about that approach also here. So yeah, so let's take this input. When we are talking about a balanced bracket, we use a stack. When we see a closing bracket and the stack is empty, it is a invalid string, right? Let's park this for now and let's go and see the next character. Next character is an open bracket, so we'll push it to stack. A closed bracket, so we'll pop from the stack, again push, again pop. So until this we are fine. Now we see a closed bracket again. What I can do right now? Until now I have found a substring which is balanced, right? So from if I'll subtract the first location, right, the first index, then I got the length, right? So in O of n time, actually I could find the length of this particular string, right? Fine. Okay, let's take this example. Instead of pushing the character, we will push the index, okay? I equal to 0, okay, and this is, let's say, our stack, okay? Yeah, so first is I equal to 0, and let's say this is our stack. So for I equal to 0, we have pushed the 0 to our stack, okay, because it's a opening bracket, okay? Again we saw another opening bracket, so we pushed that also to our stack, and I equal to 1 now, okay? Now I equal to 2, and that is a closing bracket, so we'll pop it from our stack, okay? Now whenever we see a situation where we are popping from the stack, we can actually do the max count, okay? The current location minus the top of the stack is our length so far, right? 2 minus 0 is actually 2. This is good, okay? This is working. Let's take this example, okay? So this is completely a balanced substring, right? Let's run our logic with this particular string, okay? I equal to 0. I equal to 0, we saw a opening bracket, so we'll push it to the stack. Closing bracket, we'll pop from the stack. And when we pop, calculate the max, right? Equal to I, the current location, minus the top of the stack. For this input, what we did, max equal to current location, which was the last location, right? I, which is 2, minus what? When we are done with this string, there was one opening bracket left, and that was the peak of the stack or top of the stack, which location was 0. That's why 2 minus 0 is 2, okay? So if we will use the same logic here, I minus what? The top of the stack, and the stack is empty, right? To solve this problem, what we can do, we can take a stack and we can push an element with the index -1, okay? So when we have -1, we can say -1, right? I minus -1, I is actually 1. So 1 minus -1, which is 1 plus 1, which is equal to 2. So until now 2, fine. Now we go further. For 2 we saw a opening bracket, so we'll push 2 into the stack. We saw a closing bracket for 3. We pop from the stack. Now we again calculate the max, and in this case this will be 3 minus -1, which is 4. Okay. So, okay, now we have a solution, we have an approach. So what we are doing, we are actually using a stack. Okay, first. Second, this is actually very similar to the 2-pointer technique, but the index, the last index, we are keeping it in the stack. And whenever we are popping an element from the stack, that means we are actually encountering a substring which is balanced, right? At that moment we will calculate the max. Okay, I think it might be very clear when we code. So let's go ahead and code. Okay, we are going to return an integer. So integer longest valid parenthesis, yeah. It will take a string s. Cool. Okay, we'll do some sanity check. If s equal to null or s dot length equal to 0, then we'll return 0. Okay, fine. Now we'll take a stack, as I said, stack of integer, because we are not pushing the characters, we are actually pushing the location. Okay, this is very important, guys. Stack of integer, stack. Okay, I'll call st new stack. Okay, now we will initialize the stack with one element of index -1. Okay, so stack dot push -1. Okay, we'll start a for loop int I equal to 0, I less than s dot length, so plus plus. Okay, read the character s dot char at I. So we are reading the character here. Okay, and if c equal to opening bracket, then we just push it to the stack st dot push, but we push the location, right, which is nothing but our I, right? Fine. Then else what? If stack is empty, then we return saying that it's not balanced, right? But we are not returning here, we still have to continue. And what we are doing here in this particular example, I have told you that in this particular case also we should push this index. Okay, even though this is a invalid scenario, we should push this index so that when we encounter another invalid scenario, we have a top element with the index of the closing bracket. So in this case also what we are doing, we are just pushing it, right? So st dot push I. Okay, fine. Okay, and in the else case, what we usually do, we pop from the stack. So st dot pop and throw that element right now, because we are dealing with only one type of characters, we don't have to compare anything. But after popping, in this case we are actually, each time we pop we are calculating the max element, right? So we'll say max equal to math dot max and the length so far, right? So I minus what? I is the current index minus what is there right now in the stack as the top element, st dot pick. Okay, this is what we should do. Now let's talk about one case here where the string is, let's say, closing bracket. So in that case, we will come to this else part, right? We check stack is empty. Actually, stack is not empty. Why? Because stack has one element -1, right? So stack is not empty. So we'll pop here and we calculate the max. So max is initialized to 0 initially. Oh, I have not initialized it. So let me int max equal to 0. Okay. So max is 0 and I is what? I is 0, 0 minus st dot pick. But now we have popped the -1 also, right? So this will fail, right? To address that scenario, what will we do? We'll move this st.pop to this position, okay? So that we will not do this max operation when we see the stack is empty. Max is anyway initialized to 0, so finally we should be returning 0. Okay, so this is my solution, guys. Thanks for watching, guys, and this is my channel. I'm not going to do thousands of problems in the Leetcode in my channel, but I would like to, target certain questions which are very, very helpful to, open your thought process for cracking a coding interview. You can encourage me by subscribing or liking my videos. Stay tuned and see you next time. Until then, bye, take care.